Good evening. It's wonderful to see such a full house. Is everybody comfortable now? Right? Okay. Well, I am absolutely delighted to welcome you to this, which is the first lecture in a new series for the School of the Environment of distinguished lecturers. And we are very honored to have a special lecturer with us here tonight. Before I move on, though, I do want to thank a couple of people. And first of all, I want to express our appreciation to the Sierra Club of particularly the South Carolina chapter and their president, John Ramsberg, whom I've lost track of right now. But there you are, John, who's been really instrumental in enabling this evening to happen. And the other person or people I want to thank is my staff in the School of the Environment, who have been really essential in putting this together. So again, welcome to this lecture. I am Dr. Madilyn Fletcher, the director of the School of the Environment, and I'm very happy to be able to introduce to you tonight our speaker, Dr. James Hansen. And he is the director of the NASA Goddard Institute for Space Studies. He also has an adjunct appointment at Columbia University. And I just want to mention briefly, I promise to do this briefly, a few of the honors that he has received. He is truly befitting of our first distinguished lecturer here. He won the was awarded the 2001 Roger Revelle Award for the American Geophysical Union for outstanding contributions towards an understanding of the Earth's atmosphere. He's won 2 NASA Presidential Rank Awards and an Exceptional Service Medal. He was selected for the National Academy of Science in 1996. In 2001, he got the Heinz Environmental Award. In 2007, the Dan David Prize for Achievements, having an outstanding scientific, technological, and cultural or social impact in our world, and the 2008 Commonwealth Award of Distinguished Service for his outstanding achievements in science. Dr. Hansen has made an extraordinary contribution to our understanding of the planet and the various factors that have influence on climate change. And more important, he's advanced our understanding of how we can address these potentially profound changes on our planet. So it's a great privilege for me to be able to introduce to you Dr. Jim Hansen.
Thanks very much. And thanks very much for coming here and spending your time. And I'm especially glad to see so many young people because this subject is particularly important for you. And I'm especially concerned about the intergenerational issues of equity and justice, which I will emphasize. Oops, that's not the right button. This one, I guess. Now what did I do? Let me see if I get rid of that. Just click. Escape? Escape. Okay, thank you. Now I try these arrows. Okay, that's better. All right, I'll stay away from that one. Yeah, this... There is, unfortunately, a large gap between what is understood about global warming by the relevant scientific community and what is known about global warming by the people who need to know, and that's the public and the policymakers. And it's hard for you to believe, you know, if you stick your head out the window, the weather seems great. We don't see much unusual happening. But the truth is, we have reached a point, a crisis point. And one reason that it's hard to notice it is, first of all, there are large weather fluctuations of 10 degrees or 20 degrees from one day to another, which causes you not to notice slow changes that are smaller than that. And the climate system has inertia, which is especially due to the ocean, which is 4 kilometers deep, so it takes it a long time to respond to a change in a forcing, which I'll talk about. But so as a result, the changes that humans have made to the atmospheric composition, only a fraction of the ultimate response has occurred yet. There's more that's in the pipeline, even if we don't make any more changes. And also the climate system has tipping points. You can reach a point where the changes don't occur very rapidly, but you reach a certain point and then suddenly things happen much faster because of positive amplifying feedbacks in the system. And that makes the danger of losing control of the system. And the bad news is that we have realized in just the last couple of years that the dangerous level of atmospheric greenhouse gases is much lower than what we thought. The good news is that that means we're going to have to make some changes which actually have a number of other benefits, including for human health and agricultural productivity and other things which I'll mention. That's my newest grandson. And I gave a talk last week in Virginia Tech, and they rearranged the time for my talk so I could get home in time for Jake's first birthday. But there's another reason for that. That's why I made this chart to show them. But there's another reason to show one of my grandchildren, and that is that I had talked about this subject in the 1980s, testified to Congress, and it got a lot of publicity then, but I decided that was not what I wanted to do. And so I got out of that business completely. And after 1989, I testified in 1988, 1989. And I'm not a public speaker, and I don't enjoy it, and I prefer to do science. And there are some scientists who really like it, so I decided to leave it to them. And for 15 years, I wasn't involved. I didn't go on television or anything 15 years. But then in the current administration, in 2001, I had the opportunity to speak to the Vice President's Energy and Climate group, 6 cabinet members. And actually, I got to speak to them twice. And of course, their policies were not addressed to really reducing emissions. They were but they said they were open to more information. And the president declined to join the Kyoto Protocol. But they said they were open to more information. And I did get the opportunity then in 2003 to go back to the White House and present what I thought was much stronger evidence for that we're really reaching an emergency situation. And still didn't make any progress in affecting policy. But so in 2004, over a few months period, thought about this and decided I didn't want my grandchildren to say, Opa understood what was happening, but he never made it clear. So I decided to start writing things which could be understood by a wider audience and giving some talks. And so I've done that now 4 years. I wouldn't say that it's affected any policy yet, but anyway, I have been giving a few talks. Now, one of the reasons that it's hard for people to notice anything is that the weather fluctuations are larger than global warming. And so if you look at, even if you average the weather over a month, the temperature anomaly relative to a period of climatology can be warmer than normal or colder than the climatology. Some places are red and yellow, which is warmer, and some places are blue, which is cooler. So there are more places warmer than normal, but it can go either way. But if you average those anomalies over the first 7 years of this century, you see that actually the anomalies are above normal almost every place. And they're larger at high latitudes. These are anomalies in degrees Celsius, so you multiply times approximately 2 in order to make degrees Fahrenheit. But larger at high latitudes and low latitudes because there are amplifying feedbacks at high latitudes. As ice and snow melts, it exposes a darker surface which absorbs more sunlight, and that magnifies the effect. And it's larger over land than over ocean because the ocean has this inertia, so it's only partially responded to the forcing. And larger in the northern hemisphere than southern hemisphere because the southern hemisphere has more ocean and it mixes deeply around Antarctica. So the warming so far is 0.8 of a degree Celsius in the last century, which is about 1.5 degrees Fahrenheit. And it fluctuated for a while, both for various reasons of competing forcings and natural variability, but the last 30 years it's been a fairly steady warming trend, with most of the 3/4 of the warming in the last 30 years. These are two other grandchildren, and when I talked to the vice president's group, the cabinet members, I try to explain what a climate forcing is. A climate forcing is a perturbation of the planet's energy balance. So for example, if the sun became 1% brighter, that would be a forcing of about 2 watts per meter squared, because the Earth absorbs 238 watts per meter squared of energy from the sun. And the amount of greenhouse gases, CO2 and methane, that we've added to the atmosphere, those gases are transparent to sunlight, so they don't affect that, but they're opaque. They absorb infrared radiation, or the heat radiation that the Earth emits. So they make the atmosphere more opaque in the infrared. And that means the radiation to space will arise from a higher altitude. And the temperature falls off with altitude, so that means the emission to space is reduced if you add greenhouse gases. And of course, the planet then is out of balance, absorbing more energy from the sun than it is emitting, and that causes the Earth to warm up until it gets to a point that it's back in balance again. Well, the greenhouse gases that we've added are forcing of about 2 watts. So Sophie was explaining to Connor what 2 watts of energy is. And that was 3 years ago. This is recently. And Connor's no longer so fat as he was. Now, you can ask the question, a well-educated person can ask the question, why should we be concerned about this? There have been much larger climate changes in the Earth's history. There have been huge changes, and it's arrogant to think that we can control the climate, or that we know enough to say that today's climate is the best one for the planet. This was a statement made on National Public Radio by my boss's boss's boss, the NASA administrator. And so it is a question, a reasonable question that a well-educated person can ask. And it's true that the climate has had very large changes in the Earth's history. Those changes actually tell us a lot that's relevant. Our understanding is based especially on the Earth's history. We learn more from that than we do from climate models, for example, because we never know for sure if we've got all the physics in the models right. But also, just looking at what's happening today with the climate forcings that we're putting on the system is also very useful. But to start with the Earth's history, this is the temperature near the South Pole, which fluctuates. This is over the last 400,000 years, and we get this temperature by drilling a core in the ice sheet. The Antarctic ice sheet is formed by snowfall piling up year after year, and so you can sample the snow that was laid down at different dates. And from the isotopic composition of the snow, you can tell what the temperature was when the snowflake formed. And we've been living in this Holocene, this warm period, for about 10,000 years. 20,000 years ago, we were in the middle of the last ice age, when there was an ice sheet that covered Canada, and it covered New York and Minneapolis and Seattle. But the Earth's climate fluctuates between warm periods and then gradually goes into these ice ages. And these fluctuations are associated with small changes in the Earth's orbit. The Earth's orbit is not perfectly circular, it's elliptical, but the ellipticity changes on a time scale of 100,000 years, and the date at which the Earth is closest to the Sun in that elliptical orbit changes with about a 20,000 year periodicity, and the tilt of the Earth's spin axis. The Earth's spin axis is tilted by 23.5 degrees to the plane of the Earth's orbit, and that's what gives us the seasons. But that tilt fluctuates by plus or minus 1 degree. And that's those small changes in the distribution of sunlight on the planet change the climate, mainly by, for example, as the tilt becomes bigger, then there's more sunlight at the poles, and that will tend to melt the high latitude ice sheets. And as the ice sheets melt and you get this positive feedback, a darker surface, and the planet gets a little bit warmer, when it gets a little bit warmer, CO2 will come out of the ocean, just like it comes out of your Pepsi if it gets warm. So that introduces more greenhouse gases into the atmosphere. So, and this is what we see. When the planet is warm, then you've got more CO2 in the atmosphere and more methane, and this is the temperature down here. Well, we can use this, we can compare this present interglacial period, the Holocene, with the last ice age to estimate how sensitive the climate system is to climate forcing, which, as I say, is a perturbation of the planet's energy balance. Because the things that kept the planet colder during the ice age have to be either energy coming in, but we know that on that short a time scale, the sun's brightness doesn't change significantly, or something in the atmosphere or something on the surface. Well, we know the changes in the atmosphere because in this same ice core, we can sample the bubbles of air that existed at each point in time over the last 400,000 years. So we can tell how much, well, I showed you already the graph for how CO2 changed. Those greenhouse gases cause a forcing of about 3 watts per meter squared. But the changes on the Earth's surface, mainly the larger areas of ice, caused a forcing of about 3.5 watts per meter squared. So that implies a sensitivity of 3/4 of a degree for each watt of forcing. That's equivalent to 3 degrees Celsius for doubled carbon dioxide, because doubled carbon dioxide is 4 watts of forcing. And we can check that sensitivity for that entire 400,000 years because we have not only a record of how the greenhouse gases changed over that period, but we also have a record of sea level. And sea level changes a lot. Sea level 20,000 years ago was 110 meters lower than it is now. But that water, which is not in the ocean, is in the ice sheets on the land. And so that's how we know how big the ice sheets were. And so we can calculate the forcing due to both the ice sheets and the greenhouse gases. And if we add those two up and multiply by 3/4 of a degree, we get a calculated temperature which agrees very well with the observed temperature. So it tells us how sensitive the climate is. And now we just recently got an 800,000-year record from a longer ice core, and it agrees very well on that time period also. And now the thing is that humans, I've expanded the time scale at the end just to show the modern observations. And methane is increasing far off the chart, and CO2 is increasing far outside the range that has existed for millions of years. And that, of course, those increases are due to fossil fuel use primarily, although there are also other sources of methane. And one thing that the contrarians point out and become very confused about is the fact that if you look very carefully at these variations of the greenhouse gases and the temperature, you see that the temperature changed first. It slightly changes, it begins to change a bit, and then the greenhouse gases increase, and then the temperature increases some more, and the greenhouse gases increase some more. It's a feedback on these time. And that's exactly what we expect, because the instigation for these swings is changes in the Earth's orbit. And the way they work is as I explained. So, of course, the temperature changes first, but then the greenhouse gas is half of the reason for the temperature change. The other half of the reason is the change in the surface albedo. And the instigating forcing, which is only a couple tenths of a watt per meter squared, is a very small fraction of the ultimate cause of the temperature changes. And that shouldn't be so hard for the contrarians to understand. But nevertheless, in order to show you an example, which is also very instructive, we can look at timescales on which the greenhouse gases do change first, and the temperature responds to that change. All we have to do is look at longer timescales. So what I've done here is, this is the temperature change over the last 65 million years, which is called the Cenozoic era. It follows just after the extinction of the dinosaurs. And the last 3 million years are blown up here to show you what it looks like on a higher resolution, and then the last 400,000 years are blown up here, and that's the familiar Ice Age cycle. And you can see that those ice ages were occurring at all times, but they're small. Although those are huge changes, they're small in comparison to the total change that occurs from the present back to, say, 50 million years ago. In fact, between 65 million years ago and 35 million years ago, there was no ice sheets on the planet. The planet was too warm to have ice. Now the reason that CO2, that the temperature changes on these long time scales, we know the mechanisms have to be either the energy coming in, or some changes in the atmosphere, or some changes at the surface. But the energy coming in, the sun is a well-behaved main sequence star. And we know how they behave. It is slowly getting brighter with time. It was 0.4% dimmer 65 million years ago, and that, because the Earth absorbs 238 watts, that means a forcing of about 1 watt per meter squared. The sun slowly getting brighter by 1 watt. And the continents were located differently than they are now, but they were close to their present latitudes. And so the change due to the surface changes is also small. But CO2, 50 million years ago, was about 1,000 parts per million. That is a forcing. The change from that to the amount of CO2 during the ice ages is a forcing of more than 10 watts per meter squared. So the dominant thing is the change in atmospheric carbon dioxide. That we expect that our carbon dioxide will change on long time scales because the amount of CO2 in the atmosphere depends upon the balance between sources of CO2 and sinks of CO2. The source of CO2 is volcanic eruptions associated with continental drift. As a continent moves and subducts beneath it ocean crust, the carbonates in the ocean floor are metamorphized into basalt and other rocks, and there's carbon dioxide emitted in that process, which comes out in volcanoes and seltzer springs and such. But the primary sink is the weathering of rocks. So the weathering will carry sediments down the rivers to the oceans and deposit on the ocean floor carbonates, so that draws CO2 out of the atmosphere, that process. And also there's some deposition of organic material on the ocean floor, which then can eventually form fossil fuels. But, so what was happening here? 65 million years ago, India was still located south of the equator, but it was moving north at a rapid rate of about 20 centimeters per year. And as it was moving north, it was moving through this so-called Tethys Ocean, which is now the Indian Ocean. But that ocean had long been the depot center for major rivers of the world, so it had a very young carbonaceous carbon-rich ocean sediments, ocean floor. So as India is plowing through there and subducting ocean floor, it's spewing up CO2 into the atmosphere. And as CO2 increased, the temperature increased, and then 50 million years ago, India crashed into Asia. And that began to push up the Himalaya mountains and the Tibetan plateau. And so the source of CO2 in this subduction is reduced, and the sink is increased because of the weathering of the Himalaya mountains. And so CO2 gradually decreased, and the temperature decreased until it became cool enough that Antarctica began to have ice on it, and it suddenly froze over with the positive feedbacks. And so there are two interesting things about this. The one is that if you look at the rates of these processes, the difference between the source and the sink is typically 1/10,000th of a part per million. Well, over a million years, that's a big change. 100 ppm of CO2, which is a big forcing. But the human-made rate of change is 2 ppm per year. So we're more than 10,000 times more powerful than the natural rate of change. So it's true. So the NASA administrator's right. Yeah, there were much bigger changes. But you don't have to worry about those because we're totally dominant now. Those changes occur on a much slower time scale. And the other thing that's interesting is, well, how much CO2 was there at the time Antarctica began to freeze over? Well, in a paper that'll be published next week, we show that it was about 450 parts per million. So the assumption, energy companies and governments around the world assume that we can burn all the fossil fuels. If we do that, we'll end up with 600 or 800 ppm of CO2 in the atmosphere. And we will be headed toward a different planet. The eventual response of the system would be an ice-free planet with sea level 75 meters higher. So we really can't do that. In fact, all the nations in the world, or 170 of them, agreed with this framework convention on climate change that said we should avoid dangerous human-made climate change. But nobody defined what that meant. What is dangerous? I think that the two most important metrics are extermination of species, because that is irreversible on any time scale that we can think about. There have been large global warming several times in the Earth's history, and when they did occur, there was extinction of more than half the species on the planet. And other species came into being over tens and hundreds of thousands of years. But on any time scale, we would leave a much more desolate planet for young people and unborn people if we cause extinction of a large fraction of the species. And ice sheet disintegration, it takes tens of thousands of years for an ice sheet to build up by snowfall piling up. So we don't want the ice sheets to disintegrate. And there are also important regional climate changes. And as I mentioned, there are tipping points which we need to avoid. You can temporarily exceed a given level that would be dangerous on the long run, provided you get back to a safe level. If we suddenly had 1,000 ppm of CO2 and we had that for one day, well, that's not going to cause ice sheets to disintegrate. You can have it for a while, but the question is how long? When do you reach a point of no return? And the process becomes dynamic and out of your control. Well, here's a process that we have probably pushed beyond the point of, we've pushed to a point such that we're going to lose all the Arctic sea ice. This is the Arctic sea ice. It fluctuates from year to year, beginning in the late 1970s, and then last year, but it's been decreasing as the planet has become warmer. And last year it decreased to almost down to half of what it was a few decades ago. And because the planet is now out of balance by about half a watt per meter squared, we're going to lose the rest of that Arctic sea ice in the summer. That's almost certain within the next few decades. But that is a reversible tipping point, because if we would restore the planet's energy balance or make it slightly negative, then the planet would cool down and the ice would grow back. And it can go back in 1 year. But we would have to reduce CO2 to something like 300 to 350 parts per million if we wanted the planet to restore the sea ice. The more important issue with regard to ice sheet stability, we can examine by looking at the area on Greenland that has summer melting. And that fluctuates with the weather, but the area in general has been increasing since we began to make satellite measurements in the late 1970s. And last year, the area with melting was about double what it was in the 1970s. That meltwater does not, in general, make it to the edge of the ice sheet. It will find a low spot on the ice sheet and burrow a hole to the base of the ice sheet. And it there serves as lubrication, which increases the rate at which these giant icebergs are discharged to the ocean. Now, some contrarians argued that, well, the ice sheets will actually get bigger with global warming because you get more snowfall, because the atmosphere holds more water vapor. And of course, that's true, but the common sense conclusion would be as the planet gets warmer, the ice gets smaller. And now we have a way to test that, because we have this spectacular satellite which measures GRACE, which measures the gravitational field with such a high precision that we can measure the mass of the Greenland ice sheet and the Antarctic ice sheet. And we see that during the winter, it gains mass, and then during the melting season, it loses mass. But overall, it's losing mass at a rate of now almost 200 cubic kilometers per year. And that rate, we only have these measurements for a few years, but we have other ways to estimate. And it looks like if we go back about 15 years that it was close to mass balance. And that rate of ice mass loss has been increasing over the last 15 years. So if we want sea level to be stable, it's clear that 385 ppm is too much. And probably, based on prior interglacial periods, if we want the ice sheets to be similar in size to what they are, we probably shouldn't have CO2 much more than 300 ppm. Now, another effect which is observed is the impact of global warming on the overturning circulation. The rising motions in the tropics and the subsidence in the subtropics, which causes the subtropics to be dry, that circulation cell is expected to expand as the planet gets warmer. And we observe empirically that there has been an expansion on the average by about 4 degrees of latitude. And that's beginning to affect the southern United States and the Mediterranean region and Australia and parts of Africa. And so, for example, Lake Mead and Lake Powell are only about half full, and that's probably, at least in part, due to this general climate trend. And a related effect is the increase in fires that is occurring not only in the western U.S., but in Canada and Siberia. An important effect is the melting of glaciers, which is occurring worldwide. This is a picture taken in the Himalayas, and then a more recent picture where that glacier is now gone. The glaciers in the Himalayas, in the Rocky Mountains, and the Andes Mountains provide fresh water in the summer and fall for hundreds of millions of people. In the spring, you get snowmelt, which gives you a huge flush of fresh water. But as the summer and fall go on, there's no more snow, but there's still the glaciers melting and providing fresh water. But once those glaciers are gone, then there's these rivers will be running much drier, and that's an important climate impact. In fact, these glaciers have now lost The black part of these bars show the mass loss of the glaciers as a function of altitude of the glaciers. So already a significant fraction has been lost, and there's the danger that it could all be gone within 50 years if we stay on business as usual. Coral reefs are another practical impact of, well, there's several stresses on coral reefs, but two important ones are the acidification of the ocean. As the atmosphere has more CO2, and the ocean takes up the CO2, the ocean becomes more acid. And that is destructive for shelled animals that are made carbonate or with carbonate skeletons, because in effect it dissolves the shell. And also the increasing temperature is a stress on coral reefs. So all of these things tell us that we would be better off if we aimed for having CO2 of less than 350 parts per million. Now, if we want to keep a planet similar to that which has existed for the last 10,000 years. Unfortunately, CO2 is already 385 parts per million. And when we put a pulse of CO2 into the atmosphere by burning fossil fuels, part of it disappears quite rapidly. After only 20 or 25 years, about half of it is gone. But then the rate of loss slows down, and after 1,000 years, about 1/5 of it is still in the atmosphere. The reason is that as the ocean takes up CO2, it then begins to resist taking up any more because the CO2 in the ocean can come back out. And until the CO2 in the ocean has been taken up, it has been deposited as sediments on the ocean floor, it will continue to resist taking up the remaining fraction. And that takes thousands of years to form those sediments. So you simply cannot, the bottom line is this: we cannot burn all of the fossil fuels without producing a doubling or tripling or quadrupling of the amount of CO2 in the atmosphere. What we've burned so far is the purple part of oil, gas, and coal. We've probably used about half of the oil. There are different estimates for how much undiscovered oil there is. But most experts think we're close to peak oil, which means we've used about half of the oil. And it's, you can't practically capture the CO2 from oil because that's used in vehicles, and you can't capture the stuff coming out of a tailpipe. But you could decide, so the target, if we want to preserve a planet that looks like the one we have, then we're going to have to target coal because that's the biggest source, and we could decide we'll only use coal at power plants which capture the CO2, none of which the present power plants do. If we did that, if we said we'll have moratorium on coal-fired power plants and we'll phase out the existing ones by 2030, then CO2 would peak at a value of something between 400 or 425 ppm, depending upon which estimate is more accurate for the reserves of oil and gas. And then, although that would still keep CO2 above the 350 parts per million for a couple of centuries, we could draw it down faster by means of improved forestry and agricultural practices, or if we would capture CO2 at the gas-fired power plants, but especially the reforestation in areas that on marginal land that has been deforested. But it's technically feasible to get back to 350, but it would require a quick coal phase out over the next 2 decades. And many people don't realize that coal is the main source of the excess CO2 in the atmosphere, as much as oil and gas put together. And on the long run, it's potentially even a larger fraction just because the reserves are the largest. So that's really what has to be addressed. Now, China has passed us in the past year. They now emit more CO2 than the United States. But as far as who is responsible for the climate change, it's actually mainly the United States because of the very long lifetime of the atmospheric CO2. So we're more than 3 times more responsible than any other single country. You know, the energy departments and fossil fuel companies say that it's a God-given fact that we're going to use all the fossil fuels. Well, I think that we should dispute that, and I think especially young people should dispute it. I think that it would be possible to phase out the coal CO2 emissions, and I think we need to do that. But so we have, I think, a basic conflict between fossil fuel special interests and young people and nature. And it looks like this is a very uneven fight because fossil fuel interests have money talks in Washington and other capitals. And as I say, animals are not much help. But you know, we're going to have to, fossil fuels are not going to last forever anyhow. So the world is going to have to figure out an energy source other than fossil fuels. So why not do it now instead of waiting, instead of introducing something which we're certain is going to cause a huge problem for our children and grandchildren and the unborn. And all it does is give us a little money for a short period of time. So we need a strategic approach, but unfortunately we don't have leadership that looks at the long time scale. And what has happened is the governments are now starting to talk about, oh, we know there's a problem, we agree there's a problem, and then they say we're doing this and that. It's really greenwash because what they're doing are very marginal things which don't solve the problem. The governments that are most green, or appear to be, are planning to build more coal-fired power plants, so they simply don't get it. I think that the 2 things that are essential are phasing out coal emissions, and the United Kingdom, the United States, and Germany are the most responsible on a per capita basis for the CO2 in the atmosphere, so we should be leading the effort. But I also think that we need to have a price on carbon emissions because that, but if you put a tax on carbon emissions, the only way the public will accept that is if you give all the money back to the public. Don't let the politicians decide how they're going to use the money or who. So if you just gave it back on a per capita basis, deposited in people's bank accounts on a monthly basis, then those people who want to, it would eventually be a substantial amount of money, and people would decide, well, I'm going to reduce my carbon emissions, so I reduce my tax, and I'll make money. Those people who do better than average will make money, and those people who have 4 SUVs or Hummers will lose money. But that's fine. So that would encourage innovation because those companies would want to make money, so they would want to make products that use less fossil fuels. And that would be the, I do it this way. And of course we should eliminate the fossil fuel subsidies, and that way the marketplace would choose the winners, and we should change the profit motive of utilities. Right now, utilities make more money if they sell you more energy. Their profits are proportional to the amount of energy they sell you. We should change it so that they make more money if they help you conserve energy. And then the bottom line that I want to emphasize is that I think this is really an intergenerational issue. a question of equity and justice. And our parents did not know about this, so they had a defense, but that defense is no longer viable. And I even think there's a question of legal liability for those industries, fossil fuel industries that have, in effect, hired contrarians to confuse the public about this story so that they can continue to make maximum profits. And I think, as I mentioned on that last point, I think there's likely to be increasing public protests. If I were a young person, I think I would be protesting. But this, actually, older people should be protesting. But there was this case in England, where the United Kingdom, where people climbed this smokestack and painted. They were painting Gordon Bennett on the tower, where Gordon Brown is the Prime Minister of the United Kingdom. But they got arrested, and they were charged with $65,000 worth of damage and also threatened with prison terms. But the jury declared they were innocent because they were protecting property of greater value, which, namely, the planet. And now, unfortunately, that doesn't set a precedent. It doesn't set a legal precedent. And last week, there was this case in Wise County, Virginia, where young protesters were arrested, and 2 of them were charged with 14 counts of crimes topped by obstruction of justice for blocking the entrance to the construction site for a coal-fired power plant. And they realized, and their lawyer realized, that they really had little chance of winning that case because of the unfavorable jury pool and the large number of counts against them. They just didn't think it was likely that the jury would find them innocent on all charges. And it just seems that the justice system was a case of where the justice system is working hand in glove with the fossil fuel industry. And so it's a continuing, and there was actually a story in the New York Times that said that I had encouraged young people to protest, which is unlawful. And I actually have not said that. What I've said is that now is the time to try to influence the political process. This year, and I have had press conference with the group Power Vote, and have tried to encourage young people to get active in the political process. And then after the elections, you've got to hold the people elected accountable, because they're just the pressures, the financial pressures from the fossil fuel industry and special interests just seems to be enormous. So somehow we've got to be able to hold the politicians accountable. But that reminds me, I did meet some young people today. One of them was, and I'm at the end of my talk, so I wanted Ann Fitzgerald to give her a chance to make a comment about this Power Vote.
I'm not going to speak into that. So thank you so very much. I'm scared of mics, so I'm just going to talk loudly. So my name is Ann Fitzgerald. I'm working with National Wildlife Federation on this amazing campaign called Power Vote. And I'm really privileged to stand on this stage with Dr. Hansen. So what Power Vote is all about is addressing these issues, addressing the lack of political will in our country right now. We know what the problem is. We know what the solutions are. We just have to create the urgency and the need for our political leaders to do something about it. motion that they can't hear me into the mic. Okay, thank you. So I got thrown off my game. So Power Vote is being run at 300 campuses across the nation. We're running it here at USC. It's being run at colleges, at universities, at high schools. These are students who are standing up and saying, I want a different future. I want a future that is based on clean and just energy, not a future that is based on fossil fuels, dirty money, and special interest. And that is an incredibly powerful statement. But we can't do that alone. We need everyone in this room. We need every person of every generation, of every race, of every creed to stand up and say, we want a different future. And the best time to do that is this election. This election, we have a chance to hold our leaders accountable to making a difference. And I don't care so much who gets elected as what they do after they're elected. I want to see the folks who we elect on November 4th go to Washington, go to the State House, go to our local governments and say, what can we do about global warming? What can we do about fossil fuel emissions? And that is what signing this Power Vote Pledge card is all about. The Power Vote Pledge is the cornerstone of this campaign. And I urge you to find a pen in your bag, find your neighbor who has a pen, and sign this pledge card. Because this is a way for you to get involved in this election and make a difference. This is a way for you to exercise your political will. So what are we going to do with these pledge cards? These pledge cards are going to be delivered during Power Shift 2009 to members of Congress and Senate. They're going to be delivered by thousands of youth from across the nation. Right now, we're looking at between 10 and 15,000 youth converging on Washington at the end of February to demonstrate to our leaders what we as a nation care about. And we, the youth, are standing up. And we, the youth, will continue to stand up, but we need everyone to stand up along our side. So take the moment, fill this out. It does a world of good. And then we will collect it at the doors on your way out or pass them to the aisles. And on that note, thank you so much for your time. And now ask Dr. Hansen lots of hard questions. Thank you.
Thanks, Ann. So we're open to questions. And I'm told that it would be best if you would come to the microphone to ask your questions, if you can get out.
I'm actually pretty loud, but since it is a political year, as you know, there's a move to break the moratorium against offshore drilling. And in Alaska, the way fossil fuels stay in business is everybody in Alaska gets a check for oil that's drilled in Alaska. Now, what has been proposed by my Congressman Henry Brown and several other congressmen in this state is that the state of South Carolina can decide if they want offshore drilling, and everyone in the state will get a check. Now, my thought to you, I come from Kentucky, and in Appalachia, our ancestors sold the rights to coal mining for almost nothing, and now they can go in and they can mine your land and ruin your livelihood forever because those rights were sold. So if you care about this election, I would say find out how your congressman who's running, what their attitude is on this, because we have alternatives in biofuels and conservation and other new developments that can come along. But if we're bribed, to get that check every month here in South Carolina, I'm afraid, we'll continue using fossil fuels. And my slogan is fossil fuels or fossil thinking. So.
Yeah, the people who would have us burn all the fossil fuels are clever. What the problem is, we should have started in the 1970s with a small carbon price and gradually increase that, and we would have much more efficient vehicles now, and we could have weaned ourselves largely off of fossil fuels. But we wasted 3 decades. Now we've got to do it more rapidly. But frankly, we should be. There's still so much potential in efficiency. And again, we're not tapping that because the prices are not that high. The prices quickly went up, and that's not the effective way to suddenly have an increase from $2 a gallon to $4 a gallon. You need to gradually increase in price so that people have a chance to change their energy uses. But I think the oil in places like the Arctic National Wildlife Refuge and such should be left in the ground. We have time. It gives you such a small amount of additional fuel for your addiction that we really need to break the addiction.
Hi, Dr. Hansen. Thank you so much for visiting us. I know that we've fought the oil battle on a national security basis, and as a result of that, a lot of people are pushing natural gas. I have my suspicions that that won't really solve some other issues like climate change, and I just wanted to know from an expert if my suspicions are accurate.
Well, natural gas is has the least carbon of the three fossil fuels per unit energy. And there doesn't appear to be so much of it that, I mean, we're going to, again, it's a fossil fuel which is a finite source of energy, so we're going to have to find alternatives on the long run, and we should be working in that direction. So, you know, it takes time to wean ourselves off of those, but what we can't do, for example, is say, okay, well, there are a lot of methane hydrates in the Arctic. Maybe we can go up there and figure out a way how to get the methane out of the methane hydrates. If we did that, there's a lot of methane there, and we could not do that without creating a different planet. If we're going to try to use such methane, we would have to capture the CO2 and sequester it. And again, that's just such a hard thing to do that we had better figure out what our energy sources are going to be on the long run and move in that direction.
Hi, Dr. Hansen. I just wanted to know, what do you think is the most promising alternative energy source for the United States?
The most promising, you know, it turns out that the most promising and the least expensive is energy efficiency. We use about double the amount of energy per unit product as the more efficient places. Even California is almost twice as efficient as we are in terms of carbon emissions per unit GNP, and Europe is much more efficient. So we've been wasteful, because it was so inexpensive. Fossil fuels, you know, are very cheap, and as long as they don't have to pay for their damage. So the air pollution, the health effects, and there are 30 to 40,000 people per year in the U.S. who die from air pollution, most of which is from fossil fuel burning. And there's the climate impacts, which will eventually have a big bill associated with them. And the fossil fuels use doesn't have to pay for those. And furthermore, they even get tax subsidies. So that's what makes them so cheap. They don't have to pay for their true cost. Now, I forgot your question was. It was what is the cheapest? So efficiency is actually but that is not enough. You got to have some energy. And we should give the renewables the chance to fill that need. And in order to give them that chance, we need an improved electric grid, which allows renewable energy to be moved from the places where it's abundant to the places where it's not so abundant. And that grid, by the way, could be underground. Right now, we put all of our electric lines up, and then we have to cut down the trees or cut half of the tree out, and it would be actually, we would store more carbon if we allowed those trees to be there. So we should have, I think, a major program, and I would hope the next president would have a major program to make a modern electric grid and do it in a way which is environmentally more desirable. I think that we should let the marketplace decide on which are the most effective energy sources. And if we have a carbon price that is gradually increasing, and if it's made clear that this is going to continue to increase, then there will be innovations that we haven't thought of yet. We still have, despite the fact that we've not done very well recently in terms of our science education, and even we're started to scare away some foreign scientists, or at least we've always been the United States has always been a very attractive place for people to come. And so we've had a brain drain, which has always been a positive brain drain. We bring in scientists from all over the world, and we need to make the U.S. a little more attractive, but also train our students better. And I think then we will come up with some things which I don't even know what they are yet.
I want to introduce the nuclear issue into the discussion. Here in South Carolina, we're facing 4 new nuclear reactors, 2 of which possibly could be located north of Columbia by South Carolina Electric and Gas. And in the company's application, and I appreciate you were just talking about energy efficiency and conservation, it's quite clear that the company intends to kill new measures in their service area, which is the bulk of South Carolina, for new types of energy conservation efficiency. And they also intend to kill renewables in their service area and not do anything. In an application of about 200 pages, the analysis on demand side management, energy efficiency conservation, and renewables is essentially about a page. So they plan to build the reactors, which they claim would cost about $10 billion, but the Department of Energy estimated a couple of weeks ago about $9 billion per reactor. So it appears to me South Carolina could be going down a path where the big companies, Duke and SC&G, are going to try to eliminate efforts for energy efficiency and conservation. And my organization has intervened, by the way, Friends of the Earth, against the SC&G proposal. But it's quite disturbing to see that that this is what it appears they're out to do, is stop any renewables, energy efficiency conservation in the state of South Carolina. And I'm just curious how you think $18 billion or more could best be invested over the next few years.
Yeah, that is analogous to the situation in Nevada, where I went several months ago, and where there are plans to build 3 new coal-fired power plants, which will provide a level of energy which makes it unnecessary to develop the renewable energies. And they have incredible potential with solar and with wind and geothermal. So Nevada should be a leader in these new renewable energies. Well, that will be killed with the approval of those power plants, and yet the governor and everyone is pushing for that, and of course the fossil fuel industry, and they're all in bed together. And there's a reason for that. From the utilities perspective, that's the way they make the most money. In this case, in the Wise County, Virginia, that I mentioned, that utility gets a guaranteed 14% return on whatever its costs are. They're allowed to pass this on to the customer. So it's just it's a wrong way of setting up the incentives, because the utilities make more money if they sell you more energy, and they make more money if they build more power plants. So that is what a leadership would have to address, and they would have to buck the utility industry and the fossil fuel industry, and that's a tremendous power that you're going up against. I haven't seen the leadership that's willing to do that yet, although, you know, in California, they're doing a pretty good job of that. It's so it's possible, but it has to be recognized who you're fighting and what needs to be done. And yeah, you should not be allowed to build a new large power plant, whether it's coal or nuclear, if you have not fully exploited the potential of energy efficiency. And the programs that some of these companies have, like Duke and their Save a Watt program, are so marginal that, and to a certain extent you can't blame them, because the rules are such that they would make less money if they had a good program. You got to change those rules.
I spend quite a lot of time arguing with climate skeptics. I've come across quite a lot of them, and I learned a lot from your talk, and in particular, the data and the graph that you showed of 50 million years of the impacts of CO2, and as compared to the last few 100,000 years. I know one of the questions I'm going to get is how we estimate carbon dioxide levels from 50 million years ago.
Yeah, and that's in our paper, which will be published next week, in the appendix, in the supplementary material, we show all the data. There are like half a dozen different ways of trying to estimate how much CO2 there was in the air. Probably one of the better ones is counting the stomata on the leaves of plants, because from the fossil plants, because the plants don't like to have any more stomata than necessary. They need to breathe in CO2 through those stomata, but as they breathe in the CO2, they lose water vapor, which is their vital fluid, and so they try to minimize the loss of water. And so you have these indirect type ways of measuring the CO2, and all you can say for sure was that the CO2 maximum back there was of the order of 1,000 parts per million, or maybe 1,500 parts per million, but it's not as accurate as you would like, but it's clear that it was the dominant thing, because as I showed, the other competing forcings are an order of magnitude smaller.
I'm old enough to remember what happened the last time an American president tried to tell the American people the truth about the unsustainability of our energy consumption. Jimmy Carter was a one-term president. And I don't see, and maybe you can tell me what else can be done, but I don't see any way that we can make any substantial change in the problems that you're talking about tonight without accepting and moving toward a radically different lifestyle in the United States and the developed world, unless we're willing to drastically reduce the human population of the world. It seems that one or the other or both needs to occur. Do you see any realistic possibility that politicians who are more concerned about their political future than the future of humanity will actually tell the truth and work for policies that can bring about these changes?
I see hope, or I wouldn't be encouraging people to exercise the democratic process. Jimmy Carter, he had other problems, and that probably caused his downfall, not his honesty about the fuel. He did recognize this energy problem and was encouraging measures to deal with it, although some of them, like coal gasification and things, were not probably the wisest. But whether they would have to bite this bullet of a carbon price, and I think that the public is more intelligent and willing to understand an honest presentation of the facts, especially if you package it in a way where the money is not going to Congress to decide who favorites they're going to give it to. It rather would go directly back to the public. Um, So it seems to me that it's possible that, but you're going to have leadership from the top, and they're going to have to understand the problem. And they're going to have to, the problem is a lot of the advice they get is from people who, float through these special interests. So it's not going to be easy, but on the other hand, the story is pretty clear. And a smart person should be able to understand it. So I think there's hope in dealing with it. It's just a question of, can we do it fast enough?
Yes, you talked about carbon sequestration before, and I'm just wondering, what are your thoughts on carbon sequestration? Is it viable? Is it not inherently dangerous? Just your thoughts.
My thought is it's probably technically possible to sequester CO2 in geologic reservoirs where it would be quite safe from escape to the atmosphere. But it's going to cost money. And some of the disadvantages of coal are very difficult. The mercury emissions is another story. It's hard to, you can reduce the mercury emissions, but it's hard to eliminate them. And the local effects of coal mining on especially if you use mountaintop removal, are pretty nasty in the pollution, local pollution of streams and things. So I would bet that if we put a carbon price on emissions, that it will end up the coal gets mostly left in the ground, and we find better, cleaner ways for energy. Thanks.
In the plan to tax carbon emissions, how would the government regulate how much emissions a person has?
Well, so the person would have as much emissions as they want, but they've got to pay for them. The carbon tax and the dividend that they would get is going to be the same as everybody else. So if you burn a lot of carbon, you're going to lose a lot of money. So the marketplace would then solve it. There would be no restriction on how much, just as there isn't now. There's no, you can go out and drive as much as you want. Nobody's going to tell you can only drive 50 miles a day or whatever. You can drive whatever you want. But it's going to cost, the further you drive, the more carbon you emit and the bigger your tax is.
How would you measure that?
Well, we don't need to measure it. Only thing we need is one number, and that's the carbon tax, the tax rate. And as I say, that would start moderate, but it would increase with time. And I used to say we need a carbon czar who would determine how it increases with time, because you'd like to have intelligent decisions. If you're having a recession, you don't want to increase the tax rate, so you maybe go 1 year without increasing or whatever is necessary. And if the prices of fuels drop, like they sometimes do, the supply increases, then you can increase the tax then. Because you don't want, the problem with renewable energies has been that whenever they start to look good, then the fossil fuel price drops, and then they can't compete. The renewable energies can't compete. So you'd want to choose the tax rate in an intelligent way. But I was comparing the carbon czar to the chairman of the Federal Reserve, and I don't think he's done such a good job, so maybe that's not a good example.
I guess it's a continuation of the previous question. You talk about this carbon czar, and that on one hand you emphasize that everything will be decided by the market forces, which will lead to innovation and energy efficiency. On the other hand, you have these two measures, which are non-market, certainly, the carbon czar, and then the changing of the structure of profits for utility companies. How compatible is that, and is there any methodology of actually calculating those carbon taxes, which will be accepted by voters and public.
Yeah, the thing I actually like about the carbon price is that it is so simple. And you know what I'm told by an economist when I went to Kansas a few weeks ago is, well, you don't really have to worry then much about these complicated utility regulations because the carbon price itself will take care of that. Utilities are not going to use coal as an energy source as the carbon tax gets higher and higher. So you don't, still, I think, efficiency, I'm still not sure that you don't want some mechanism to a stronger inducement for utilities to encourage people to be as efficient as possible. But the price that the consumer pays is going to be proportional to this carbon tax, so there will be incentive for consumer to be efficient. And so I think largely that one number takes care of it. What is the carbon price? And that should be determined empirically. You will see as you're going along what is needed in order to reduce the carbon emissions, the fuel use.
If you take a flight, if there's a carbon tax, you're saying that the cost of the fuel would be embedded in the ticket?
Yeah.
Okay.
Yeah.
And the same thing if I bought bananas from
Exactly.
far
That's
away,
yeah.
the banana price would be higher because it had to travel.
Right. Those are the kind of distortions that we have right now. You got to eliminate all those distortions. We import food from New Zealand because there's zero tax. In the 1940s, governments decided they should encourage the airline industry, so they decided they had an agreement not to put a tax on aviation fuel. And 60 years later, they haven't changed that. So that's crazy. We should have a carbon tax, and those kind of things would be fixed if, in an automatic way, if we did that.
There are several billion people on Earth in the undeveloped countries that understandably would like to come up to our standard of living. And the world's population is projected to grow from about 6 billion today to about 9 billion by the end of this century.
Which is a big improvement over, 10 years ago it's projected to grow to 10.5 billion by 2050.
Nevertheless.
Yeah.
Japan seems to be about the most energy efficient developed country today. Produces about twice the GDP that we do per capita for unit input of energy. If you're not going to do nuclear, can solar energy support the coming demand for energy, which would be roughly 4 to 8 times the present use of energy worldwide?
Well, that projection of 4 to 8 times is the kind of thing the energy departments make. I'm not sure that that's really viable. Their projections always assume this growth curve, which if we in fact had a carbon price, I don't think that curve would grow that way. But nevertheless, there are 2 parts to your question. I think population is one thing, but having a lot of children has become unpopular with most women, and educated women, so that in developed countries, the fertility rate is actually in most countries slightly below the replacement levels. Still, population will go up because the life span is increasing. But there are some countries in Africa and India where the growth rate is still pretty large. But yeah, it's certainly a problem, but it's one which has gotten better, and we.
The
I don't know what
bottom
else.
line question is, can solar do this,
Yeah.
even with a four-fold increase, if you don't
Well,
want, if you don't want to buy 8?
It would take a substantial area. There's actually enough area in the desert to do that, but it's, as I say, it's not clear that that you would need a storage mechanism if you're going to use solar as the primary source, because it is intermittent, and you would need a good distribution system. So it does raise the issue of whether you need other things. But again, I do think the market mechanism should decide that. But the one question that everybody wants to know, do you need a base load power? And if you do need a base load constant power, is there a choice between, are you forced into making a choice between coal and nuclear power? And I think that I think that we should have continued research on next generation nuclear power. The kind of nuclear power that would burn, the fourth generation nuclear power that would burn nuclear waste and would not require us, because we have so much nuclear waste already, we wouldn't have to mine uranium for several hundred to 1,000 years. But that's not yet, I'm not yet ready to advocate nuclear power. I think we haven't exploited energy efficiency or renewables to anywhere near the extent that they're capable of providing. So I think that should be the first priorities.
I have a comment and a question. I think that what you said about reconstructing the grid is one thing that's really necessary, as you were talking about, do we really need to have baseload generation? And the trend now, I believe, is moving away from the giant base load and moving into distributed energy systems. And that's my comment. My question is just to reveal my ignorance to everybody. I have difficulty in speaking to policymakers who want to speak to an expert such as yourself. And I do not have the command of the facts. And when I try to take something with me, notes, or, I get derailed because they have the opposition's arguments. So my question is there a cliff notes that you have for people? Because, our policymakers tend to know even less than I do, but I have to know a lot more than I do to be convincing, since my background is not science, it's not mathematics, and so on. Thank you.
Yeah, I wish we had better cliff notes than we do. I'm actually thinking of writing some this winter. Yeah, that's the problem. And I'm afraid I don't have a recommendation for a specific book that really handles what you want.
Much of your data is collected by NASA satellites, and as I understand it, due to budgetary cuts, et cetera, some of the satellites that were programmed to be put up in orbit are no longer going to be ones that take the measurements that you've been talking about. Is that a major problem that you foresee in the near future?
Yeah, that's a problem, and there's an Academy committee that wrote a report which trying to stress the problem with the great reduction in the satellite missions for looking at the Earth, and the fact that in the current administration there was a decision made that NASA should focus on going back to the moon. Which some people thought was in order to to take away the emphasis on looking at the Earth, because they'd rather not look at something. If you don't know about it, it's not a problem. I would hope that in the next administration there would be a little more emphasis, because there are really spectacular measurements like this gravity satellite, and there's no follow-on satellite for that that's on the books. And there are other things we can do with modern technology which should be done. And you're right, the number of Earth-looking satellites has been on decline. Okay.
Yeah, you have made a lot of emphasis in the carbon price and, well, how it's needed to make more regulation of this. But I also consider that the market by itself, if the renewables can be competitive, that can give the edge to make an offer in terms of use market. You fight money with money. And that language has not been spoken to these people. For that reason, they are deaf. So do you think that the renewables can have, in the long run, that competitive edge?
Well, right now, renewables are still, if with the price of oil dropping, renewables are at a disadvantage, and suddenly the big investments in them are not looking as good, or are declining. So that's why you need to make the fossil fuels pay for the damage that they're doing. If you'd at least remove their subsidies and put some price even on the damages that they cause to human health, and if not the climate, then renewables would do very well. And on the long run, I think renewables will do very well. But you know, we've had a century to build up the technology for the fossil fuels.
The oil man of long standing, T. Boone Pickens, has proposed a plan to assist our dilemma, at least as he puts it, by reducing the amount of gasoline that we burn in cars, automobiles, and other forms of transportation, and trading that gasoline for natural gas, replacing the amount of natural gas that we would be using for the generation of electricity by wind power. I have some problems with that. I don't see that it's really helping the transportation industry, except that the natural gas does produce less carbon dioxide than gasoline. But we're still basing our transportation on fossil fuels.
Yeah.
And it seems to me that all we're doing is, all that proposed solution would be just giving us a little bit more time to continue doing what we've been doing in the past. Now, I was wondering if you had any...
No, I agree with you completely that the half of his plan is useful, to trying to really see what we can get out of wind power in this wind belt in the central U.S. But vehicles, we're going to have to find a way. People are not going to give up personal vehicles. That's just too great a asset. And so we have to find a way to power our vehicles which does not produce CO2. And there certainly are ways to do that. The electric car with the electricity coming from non-fossil fuels is one way, but by itself has a limited range. And you know, there are other possibilities. There's an interesting one mentioned in the recent book of Tom Blees, which is boron. You know, if you put, even if you could use iron dust, and if you make it fine enough powder, it'll burn. And boron and fine powdered boron will burn and make boron oxide and produce the energy to drive your car. And you catch the boron oxide, and then you take it back and put energy into it and take the oxygen off, and you got the boron again. Well, that actually would work, and you could get the boron. You could buy the boron in a 7-Eleven store. So that would eliminate the need for gas stations. So you can be sure that the fossil fuel industry is going to be not very excited about this. But there are ideas like that which would work on the long run. The only reason we have not really developed them or worked on them is that fossil fuels are so cheap. You drill into the ground and hit an oil pocket, you can bring the oil out for You know, it used to be 10 cents a gallon and sell it for a lot more. So, yeah, so I don't think that using natural gas to power gasoline, to power vehicles is a long-run solution at all.
Shall we call it, bring it to a close now? Dr. Hansen, I do want to say to you, first of all, I want to thank you all for coming, and there are some refreshments outside the door if you want to get your energy up again. But Dr. Hansen, I do want to thank you so much for sharing your time with us and sharing your thoughts and your knowledge. It's just been a great honor for us to have you here.